We've talked about what a log actually is. So what it actually is, it's a function that is actually on your calculator. And so we're going to do a couple questions as practice for helping us use our calculator to put these in. On your calculator, you should see an LOG button, and right next to it, you should see an LN button that's on there. As long as you have a scientific graphing calculator, you should see those buttons that are on there. So what you do is it's like a function, so we put a number into it, and it's going to spit us a number out as a result. Now, thank goodness these are already programmed in our calculator. The way they used to do these is they used to have a big book that you would have to look the value up on a table, and so thank goodness we don't have to do that anymore. No, I'm not that old. I did use a calculator in my age, but that's what my dad told me that they used to use, is these big tables you had to carry around. All right, so let's go ahead and practice by putting that in there. This one needs to be rounded to the nearest thousandth, so that's 3 decimal places. So you should be getting 0.699. Now, if you tried this on your calculator and you got an error on there, that means you have a special calculator that requires you to put the number in first and then the log number afterwards. So if you didn't get this and you got an error, put 5 in there first, then hit the LOG button to get the answer. Now let's do the same thing with LN7. So this one you should get 1.95. That's rounded to the nearest hundredth. Again, if you get an error message on that, that means you might have to put the number in first and then hit the LN button afterwards. So your calculator is programmed to only do 2 types of bases. This here is a log base 10. If you see a log that does not have a number underneath it, that's automatically a base 10. And LN is a log base E. Those are the only 2 that most calculators will do. Some graphing calculators you might be able to do different bases besides these, but most calculators you can only do log base 10 and a log base E. So the question is, well, what happens if we have a log of a different base? Then how do we do that? Okay, glad you asked. Okay, the next video we're going to talk about is a property that we can use that's going to allow us to find logs of different bases. Let's take a look at that next. Okay, so next thing we want to talk about is equal basis property. This is going to allow us to find logs of different bases. So this is saying that if the bases are the same, that means that the exponents are going to be equal to each other as well. Now sometimes this has different names depending on which textbook you're using. Sometimes it's called the equivalent property of exponential functions, but that's just too long. So I'm defining it as equal basis property here, and that's what I'll be referring to it as. So we're going to make use of this property in the next couple problems in order for us to find the exact value of a log. If it's not a log base 10 and not a log base E, then this property will allow us to find a couple more logs of different bases without using our calculator. In this problem, we want to find the exact value, and we notice here that we have a base of 4, and a base 4 we cannot do on our calculator, so that's why we have to use a different process to find that. What we're going to do here is we're going to let that equal x, and eventually we're going to solve for x, and that's going to be the answer to the whole problem. We want to get this out of the log form into something that's exponential, and so that way we can solve for it by using the equal basis property. So we talked about this earlier in this section, how you can convert between log form and exponential. The way that we're going to do that for this one is we're going to take the base 4, we're going to raise it to the number after the equal sign, and that's going to equal whatever we have left over inside. So what that looks like, it's going to be 4 to the x. 4 raised to the number after the equal sign is going to equal everything else left over, so 4 to the x equals 64. Now that we have this, we want to use the equal basis property, which means that we have to write both of these in terms of the same base. Now, 4 and 64, both of those could be written as a base of 2, but that might be a little bit more work than we need. If this number on the right-hand side can be written in terms of the base on the left-hand side, then that's better. We should go ahead and use the highest base that we can to where we can get both of them equal. 64 can be written as 4 times 4 times 4, or 4 to the third. And so again, I'm going to use that instead of writing it as a base of 2. So 4 to the x is equal to 4 to the third. Since both the bases are equal, the exponents will be equal, which means that x is equal to 3, and that's going to be the exact value for this. So this problem we were able to do by using equal basis property, and we didn't have to use a calculator at all for this. So now let's take a look at another example. Okay, for this next example, we have a log, and it does not have a base on it. What I mentioned earlier when we did the calculator examples is a log with no base means that that is a log base 10. So even though it wasn't originally written that way, if you see a log with no number, that means it's a base 10. We'll do the same thing that we did before. We're going to go ahead and set it equal to x, and then we're going to change it from log form to exponential like we did the previous example. So we're going to do the base raised to number after the equal sign. So we're going to do 10 to the x is going to equal 1 over 10,000. So here, we want to write both of those in terms of base 10. We can do with this one. So on this side, we need to work with that a little bit. Let's write this as a base of 10. That's going to be 10 to the 4th power because we have 4 zeros that are there. Okay, so 10 to the 4th. Well, then we can change this into a negative exponent. Whenever we bring something across the division bar, the exponent changes sign. So 10 to the x is going to equal 10 to the negative 4. Now both the bases are the same, so now we'll set the exponents equal, and we get x is equal to negative 4, and that's going to be the exact value for this one. Now keep in mind, this one you could have actually done in your calculator because it is a log base 10, and that is a base that your calculator can do, but this is how you would do it without a calculator, just by using equal basis property here. Mainly is how we did that, and also changing it from the log form into exponential.